Hello everyone. In this session we are going to start the unit 4. Unit 4 consists of two parts. One is the map reduce and the second one is the yarn concept. So as the part of that we are starting the map reduce concept in this session. So here we are going to introduce the map reduce, and as we discussed, the distributed environment is having two components. One is the distributed storage and the second one is the distributed processing. Distributed storage already we discussed as HDFS, Hadoop Distributed File System. In the Hadoop concept only, there is the map reduce concept. Originally it was developed by Google, and based on that Google paper, in the Hadoop they have implemented the map reduce with the same name. So that is the distributed processing. So process in the distributed files already we discussed as the part of the introduction. So here already the data is distributed and the process is initiated at one place and it has to get the data from different places. So the data has to be traveled through the network so that it consumes lot of bandwidth. So that is the main issue for here. So instead of copying the entire data into one machine, it is better to copy the process into various places, meaning that wherever the data is available, there we can replicate the process and we can execute the same process on all the machines, and then we can aggregate that onto a single process so that we will get the final output. So this is the idea of the distributed process. And if we observe that, this is just a recap, that there is the HDFS, Hadoop Distributed File System, and there is the map reduce. On top of HDFS we have the map reduce, because we should have the data. If you have the data, then only we can process it. So HDFS and map reduce, the combination is called the Hadoop. On top of that, number of ecosystems are developed. So the map reduce is there. Now the distributed process, already we discussed about that. The process is distributed onto various machines and it can be executed. Now let us see what is the process concept, how the process is going to execute. So see here, steps in the execution of the process. It is not on the distributed manner, it is a regular process, how the process will be executed. The process will take the data, it may be from the secondary storage or the primary storage, whatever it is. The process will take the data and it will perform some operation and it will produce some output. If the data is huge, that will be in the secondary memory, that is in the disk. And the output is also the same. If the output is large amount of data is there, then we can go for the secondary storage. Of course, sometimes we have to upload into the file, okay, the output. Now in this case, let us say for example, if the data is very large which cannot fit in a single machine, then the option is we have to split the data into different parts so that we can divide the data into different parts and we can store that into different machines. So they can be called as the blocks. In the HDFS we discussed about that in the HDFS. In the similar way, here also we will divide the data into parts. Here the parts are called the splits. We will create the splits in the number of splits, and again if you initiate the process at one place, the same problem you will get, that is here the data has to be transferred to the machine where the process is initiated. So what is the solution? Already we discussed that for wherever the data is available, for that data chunk or for that data part, we have to create a separate process. Now here there are the data splits, here data 1, data 2, the data 3, these are the splits of the data, and for each split we will create a process, separate process, and that process will be executed on the particular split of the data and it will produce the individual outputs. Now these outputs are not the original outputs, these are the intermediate outputs. So the intermediate outputs have to be aggregated so that we have to combine them by using a separate process, that is the that will aggregate, it will take the outputs from all the processes previously executed, and then they will be combined by using some other process, and it will produce the final output. Now if you observe, there are two kinds of processes we are executing. First one is the process which is executing for each and every split, and the second type of process is to aggregate the outputs of all the previous processes. So here the process which is initiated for, or which is executed for each and every split, that process is called the map process. And the process which is aggregating, or the next level of summarization, we can call it as a summarization, that is called the reduce process. So these are the two phases of this programming model. Let us see a small example how it is beneficial for our purpose. Now let us take the small example, that is addition of the array elements. Here we are having the array elements. Let us say, for example, 9 elements are there. If you want to perform this operation on a regular basis, how can we perform that? That is, if you observe, if you observe that here we have to take a variable sum, and I want to calculate the sum of all these elements. We have to take the first element. Initially we have to take the sum as 0, and we have to take the first element and add that to the sum, so that we will get 0 plus 1, and then take the next element, again add that to the sum, and so on. This is the process. This is our regular program to find the addition of all the numbers, all the elements. Now let us calculate a rough calculation. Let us have a rough calculation that each addition operation is taking 1 second. Let us say 1 second. It is taking 1 second for one addition operation. So how many addition operations are there? Here there are 9 addition operations are there. So first initially we are taking that 0. For that 0 we are adding 1, 2, 3, 4 and so on up to 9. So 9. So 9 addition operations are performing. So total we need 9 seconds to execute this. We need 9 seconds to execute this process. Now let us apply the distributed processing environment. Now if you see that the array, we are dividing this array into 3 parts. Let us say, for example, these first 3 elements are in the first part, and the second 3 elements will be in the next part, and the next elements will be on the next part. So like this we are having the different levels, meaning that we are having the different splits of the available data. Now what the map process will do is, it will perform the operation of this, that is 1 plus 2 plus 3. That operation will be performed here, and the next one is 4 plus 5 plus 6, next set, this operation will be performed here, and the next process it will perform the addition of 7, 8, 9, and then the output will be produced by each process, so that 1 plus 2 plus 3 is 6, and this is 15, and this is 24. Like this it will produce the intermediate outputs for each and every process. And then the reduce process. The reduce process, it has to take all these outputs and it has to aggregate and combine them, so that we are going with that. So it is taking 6, 15 and 24, they will be added here, and it will perform, it will give you the final output, so that we are getting the final output 45. Now how much time it is taking? Let us say, for example, for this map operation it will take 3 seconds, because it will take 3 seconds because there are 3 elements have to be added, and it will take 3 seconds, and this process will also take 3 seconds. So, and then this process will also take 3 seconds, because there are 3 inputs, okay, 3 three elements have to be added, and then it has to produce the output. Here the thing is actually total 12 seconds, 3 plus 3 plus 3 plus 3, total 12 seconds are required, but you have to observe that all these three processes can be executed in parallel, so that for all these three processes it will take only 3 seconds, and for this process it will take 3 seconds, total 6 seconds will be taken. So if you are taking the regular addition of the elements in the regular process, it will take 9 seconds, but if you use the distributed process in this simple example, it is taking the 6 seconds only. So this is in this way we can get the benefit of distributed processing for the large amounts of data. Here we are taking this very simple example and we are assuming that 1 second is required for one operation. Actually it is not. It is in the microseconds it will be performed. Okay, nanoseconds and microseconds, that we are not going to discuss. We are just taking that 1 second. This is just for analysis. Now let us go with the what are these processes, what is the entire process, what is the terminology behind this. That is MapReduce. The MapReduce, it is the framework for the parallel processing on the commodity machines. Parallel processing will be performed and it will break the process into two phases. One is the map phase, second one is the reduce phase. And the map and reduce phases, they are taking the inputs and they are producing the outputs also in the form of key value pair. This is the important point here. The map and reduce processes, they will take the key value pairs only and they will produce the key value pairs. Okay, and the user can define their own methods, that is the map and reduce method, and if he require he can define his own other methods also. Now what is the map phase? In this, first we are going to discuss about the map phase and then reduce phase. In the map phase, it takes the input data from the split and process it. We have seen that. Okay, and then after performing that process, it produces the output and stores in the local storage. Where this process is executed, what we are discussing is distributed environment. Some part will be executed in one machine, some part will be executed on another machine. So where the process is executed, at that local storage only the corresponding output will be stored. Okay, and then local storage, in the local storage, and it partition the output into regions. Let us say for example, if the user wants to get multiple outputs, let us say for example, if he want 2 outputs, then the calculated output that will be divided into 2 parts for output 1 and output 2. For every map output, that is every intermediate output, that will be divided into 2 parts because we need 2 outputs. If you require 5 outputs, it will be divided into 5 outputs. They are called the regions here. It will be divided into different regions based on the number of reducers, right? And how many number of reducers are required, that is depending upon the number of outputs. If you need 5 reducers, if you need 5 outputs, 5 reducers will be created. If you need 2 outputs, 2 reducers are required. Now a separate mapper will be created for each input split, meaning that if you have 5 splits, 5 mappers will be created. You can see that the mapper, the words are a little different. Map phase, mapper, map method. So see here, a mapper will be created for each input split. For every part of the data, a mapper will be created. And each mapper invokes a user defined map method. A user defined map method, please remember this. Mapper will call the map method. How many times it will call the map method? That is depending upon the number of rows in that particular split. The data is divided into splits and each split is having number of rows or records. How many number of rows are there? Those many number of times the map method will be called by the mapper process, right? How many number of mappers will be there? That is the number of splits available, those many number of mappers will be created, right? and then the map method can be invoked any number of times, that is that, and the output locations will be sent to the job tracker. So the job tracker will collect all the locations of the intermediate outputs. And the reduce phase, what the reduce phase will do, it will, the job tracker, from the job tracker it will take the output locations, intermediate output locations, and it will collect the data from the corresponding regions, and then it will shuffle and sort it, and then it will merge the all the outputs, and then it will process the merged data and it will produce the final output. Now each reducer invokes a user defined reduce method. Mapper will call the map method, reducer will call the reduce method. So we can continue in the next session.